This is Algebra 2, Chapter 3, Section 7, in which we will be studying Cramer's rule. Now, we looked earlier this year at various methods for solving systems of equations. We did graphing method, substitution method, elimination method. Those were in sections 3.1, 3.2, somewhere in there. Okay, there's another method that uses matrices. There are a couple of them. We're going to study in this one the method called Cramer's rule. Now, in order to use Cramer's rule, we need to know how to find something called a determinant. Now, only square matrices can have determinants. Only things like a 2x2 or a 3x3 or a 4x4 can have determinants. A determinant is just a value that comes out of the numbers in the matrix. And we're going to look at how to calculate that. When we're looking at a 2x2 determinant, there's a formula, AD minus BC, assuming that this is our matrix. Okay, what you're doing is multiplying diagonally downward from upper left to lower right. That's where this first piece comes from. Minus multiply diagonally the other direction. Diagonally down to the left, that gets you the other part. Okay, I'm going to get these two arrows out of the way so you can see that again. AD minus B times C. Okay. We're going to do a couple of determinants. The first one I'm going to do in a lot of detail. Okay, we're going to multiply down diagonally, negative 6 times 8, and then minus negative 7 times 10, down the other direction. Well, negative 6 times 8 is negative 48. Negative 7 times 10 is negative 70. We do the arithmetic and we get the determinant is 22. Okay, let's look at another one. We've got another matrix. It's a square matrix, 2x2. We're in business. 7 times negative 4 minus 9 times 5. That's negative 28 minus 45 gives you negative 73. Okay. Now, in order to use Cramer's rule, we have to build some determinants. And for a 2x2 system, it works like this. Let's say we have these two equations. All the letters that are not x and y are going to be numbers in your problems. Then x is equal to a couple of determinants, one over the other, and y is equal to a couple of determinants. Okay. Things I want to draw your attention to. The denominator is the same in both cases, and that denominator comes from the coefficients on the variables. You see it there, A, B, D, and E, A, B, D, and E, A, B, D, and E. Now the numerator, what happens is you take the constant terms, the C and the F. When I'm solving for x, I put them in place of the x numbers. So A and D go out, C and F go in their place. When I'm solving for y, the C and F go in place of the y numbers. So B and E are out, and C and F take their place. Okay, that's the magic formula. Let's do a Cramer problem with 2x2. We have a couple of equations, 8x minus 5y equals 70 and 9x plus 7y equals 3. Okay, we're going to build our Cramer matrices. I always build the bottom one first because I can just look at it and get it. 8, negative 5, 9, 7. Now up here, the 70 and the 3 go in place of the x numbers. So 8 and 9 are out. 70 and 3 take their places. The y's just stay what they are. Well, now we can do this arithmetic. 70 times 7 minus negative 5 times 3. 8 times 7 minus negative 5 times 9. My trusty calculator helps me out and gets me to a final answer of 5. Okay. Same idea over here on the y. I've got the same denominator, and instead of the numerator that I had over here for x, now the 70 and the 3 are in the y's column. The 8 and the 9 are back in place in the x's. Okay, we're going to do the same kind of arithmetic. 8 times 3 minus 70 times 9. Now you'll notice I've already got 101 down here in the denominator. I didn't do this arithmetic again. It's the same matrix. It better be the same answer. So now when I do the arithmetic, I get negative 6. So now I have values for x and y, 5 and negative 6. Okay. Doing this with a 3 by 3 system is the same basic idea, but it takes a little more work. All right. And the way that we're going to do this has several different names. I was taught that it's called sweeping the diagonals. The first thing you have to do, and this is really kind of bizarre, but it works perfectly, is you copy the first 2 columns to the outside. Okay, copy the first 2 columns to the outside. Now we're going to do the same idea of multiplying down and to the right, down and to the right, down and to the right. All right, we're going to have 3 multiplications going on. And I'm going to get those arrows out of the way so we can see the numbers now. We're going to go down and to the right, down and to the right, down and to the right. We're going to add those values together. Okay? And I'll trust you to do the arithmetic with your calculator to make sure you can generate this. Okay? That's the down and to the right part. Now remember, the rule was down to the right minus down to the left. Now we need to go down and to the left. Down and to the left. Down and to the left. Okay. So we'll do the down and to the lefts. And we'll add those 3 things together. Put the arithmetic through in the calculator. And now it's the down to the right minus down to the left. Gets me my determinant. Okay, went through it a little bit quick there, but I didn't want to bore you with the arithmetic. I know you can multiply numbers together. I wanted to show you what needs to be done. Plus you have this where you can refer back to it. So now let's do a 3 by 3 with Cramer's rule. And we're going to use graphing calculators for a good bit of this, and I'll show you how to do that in class. I still want to see your setups. Okay, I've got my denominator, it's the coefficients, and I put the constant terms in the x column. Okay, the y column and the z column stayed the same. For the y value, the constant terms go in the y column and the other 2 stay the same. In the z value, we'll put the constants in the z column and the x and the y stay the same. Now you'll notice I've got this little squiggle here. Okay, there's no sense in making you write out this matrix again and again. We know it's going to be that matrix. So I'm going to let you use my little shorthand here and just put a squiggle to say it's the same thing, so you don't have to calculate it. Now our graphing calculators will do these determinants for us. Once you've shown me the setup, I'm happy to let you use the graphing calculator. to generate these answers, and I'll show you how to do that in class. Okay, it's fairly straightforward with the calculator. So I'm not going to bore you going through the arithmetic of how you get all these values. But x is -4, y is 5, and z is -1. If you want to work it out doing your diagonal down to the left, or down to the right, down to the right, down to the right, you can. And it works the same way. So Cramer's rule, doing a lot with determinants. A lot of multiplication, a lot of addition, some subtraction, a little division thrown in for fun. If you had questions along the way, hopefully you wrote those down. Bring them in with you, and we'll see you in class.